This first session is going to be on Solidity, which is the Ethereum smart contract language, and then the second section will be on like connecting to the smart contracts and creating like an interface for them. I'll explain more about it because it probably doesn't make a whole lot of sense, but yeah, I'll give you the structure to that throughout these next few slides. So yeah, what is blockchain? It sounds kind of like scary or boring or whatever. I remember hearing about it a few years back, and it didn't really interest me because, yeah, I don't know. But it's basically just a big database that you can modify, and everybody stores this database and makes sure that it's correct. And you have to pay to modify it. You don't really have to think about, oh, how does the blockchain work or whatever to be able to use it. It definitely helps, but all you need to think of is a big database that changes with transactions. Ethereum is Bitcoin is the number one blockchain. Ethereum is the number one blockchain with programmability. Bitcoin just added that recently, but it's not really in the eyes of the public. Ethereum is the number one place to go if you want to do anything in blockchain. That's the most solidified. And smart contracts, what are smart contracts? So smart contracts are very similar to Java's classes. It's pretty much object-oriented programming. And these smart contracts are code that you write and deploy to the blockchain. So they operate on the blockchain, meaning the variables are stored in the database, and this code tells people how they can interact with those variables. So it's just like putting a class on the blockchain. And yeah, this art piece on the right here, don't tell on me, but I stole it from Snoop Dogg. He's actually one of the number one collectors of NFTs on Ethereum. And this was last sold for just over $1 million to Snoop Dogg, which he goes by the name Kazomo de Medici. So why should you learn? This space is one of the most exciting out of anything. I've looked at a bunch of different areas of computer science when I started out, and I gravitated towards like web apps because Facebook, Instagram, like they're all web app based. This is just, it blows everything out of the water with how exciting and brand new it is. Like every month there's something new that everybody's hopping onto and like throwing millions of dollars into. It's nuts. Like the volume and the stakes that are on the blockchain, it's just like nothing else. It's also super easy to get into because like it's only 5 years old basically. The biggest push into the blockchain, like into Ethereum, was like 3 years ago, and before that it was just like a very small community. So if you're coming into it, the seniors are 4 years into it, whereas if you're doing web development, seniors can be like, I don't know, 20 years into it. So it's very hard to catch up as a student. I feel like I've caught up in just the last like 3/4 of a year. And so I highly recommend it to anybody that's still kind of trying to figure out what they want to do. There's also so many hackathons. They're usually hosted by ETH Global, which is just a group that hosts these hackathons, and there's like insane prize pools, like in the hundreds of thousands at least. I've participated in 2, and I think like personally I've made about, I don't know, 2,000 to 3,000 just from participating. Yeah. And then like I'm highlighting a lot of the money aspects of it. And I mean, I think that is very enticing for some people. It's definitely enticing for me. But it also just, it's exciting regardless of how much money is in here. Yet if you're looking at starting in this space, I've seen people on Twitter talking about junior developers that have like just talked. Yeah, I do like money. Yeah. I've seen junior developers that are talking about like they're hiring in the 200s. I think that's a bit high. But there's so much demand and nobody really has put the effort into learning Solidity and is confident in their skills. So there's a lot of demand and little supply of developers. And yeah, there's startups launching constantly. I've been able to start my own company, and it's like basically it was fast track through it. Every other, I couldn't imagine starting a company in the like Web 2 space, but here there's investors ready to like throw money out. It's insane. So smart contracts, I touched a bit about it. I pretty much explained this, but yeah, it's think of it as a Java class or a C class even, and you deploy this piece of code that has state variables, and those state variables can be modified by the functions that you create. So people call this code is law. It basically defines how your platform operates, and nobody can do it differently from how you design it. So it's really cool because you get to create these people call them protocols. That's the common thing for it. But you're able to create this application that can hold like crazy amounts of value in it, and you get to decide how users are going to interact with that value, and it will never change. It's not like anything else. It's a very cool space, and it takes a little bit of learning to understand. But I'm hoping to kind of teach a bit of that as we go along. Solidity, as I mentioned, is the most popular language for smart contracts. All the top chains, Ethereum, Binance Smart Chain, Polygon. There's a bunch of blockchains that use Solidity, and it's the number one for everything pretty much. There's also Rust that a new chain Solana uses. I know Cardano has released Plutus, but they're pretty secondary compared to Solidity. So yeah, we'll dive right in here a little bit and kind of describe the state variables and the syntax of the language a bit. Don't get too caught up into it because I find that it's definitely way easier to learn as we go through it, and we'll be creating a contract later on. But I can just walk you through these to begin with. So primitive types are pretty similar to like C, I would say. We have just Booleans, UINTs, unsigned ints, integers as well. Integers are a newer thing. They're a lot less common. Most people just use UINTs. There's addresses, and addresses are something that's not anywhere else really. The address is a wallet. So the address is the wallet or the user, and that's how you identify who's who. It's a byte string. And then you also have just a string. You also have arrays down here, which are dynamic or fixed length. Both are common, I guess. Structures, very similar to C. I think it's actually the same syntax. Correct me if I'm wrong, but you can have a struct here. And yeah. Enums are also, you can create enums as multiple selectors. So this is like a switch. They're pretty common in other languages as well, like TypeScript. And this will let you just kind of, make a switch. You can start or stop. this switch. This is what I created. Mappings are also similar to like I think they're in Python mappings, but basically it's an array that you index by something else. So I can create a balances array and index it by addresses, and that way you could go balances, square bracket, put in an address, and then okay, yeah, so similar to a dictionary, and then you can get out that value there. We'll see more of this as we keep going. That's all types, basically, primitive types, structures, and there are some extras, but they're barely ever used, and a lot of them are newer, so they're not. Yeah, they're just not used that much yet. They might be in the future, but this is basically these are the basics that you. There's also different things. These are kind of more of the different things that you see in Solidity that you don't see in Java or C. You have these global variables. Message dot sender. This is the address of the person that's calling the function. So as I said before, anybody can modify something on the blockchain, but you have to call that function with a wallet and pay for that function. So these two variables here are to do with that. This is the address of the function caller, so message.sender, and then this is the value in ETH that the person is sending. Yeah, you can call a function, and you can also send Ethereum to that function, or send Ethereum to another address or whatever. We also have block.number and block.timestamp. Ethereum, if you think of it as a big database, there's updates every 15 seconds, and those updates are called blocks. And all the function calls get packed into a block and updates the database. So these blocks are can be checked by the chain when it's going on, so you will know what block number your function call is in, and the timestamp. These are not so important. You probably won't use them a whole lot, maybe for more advanced things, but yeah. We also have, we'll go down to the bottom here, we have functions, and we can just kind of get an idea of the basic syntax of a function. So I'm not sure what to compare it to, but we can just go through it. So you would declare a function with a function keyword, and then you can name your function, input your parameters, add some modifiers. We won't really touch on modifiers, but there's these modifiers are what we can touch on. So there's private, public, internal, external. So you just put those modifiers there. I'll explain those in a second. And then you also add return values. This is something I guess isn't always common. You can return a single value. You can also return multiple values, which is interesting. But yeah, this is a syntax for a function. And these modifiers, there's public, private, internal, external, and view. When these public and private are pretty similar to like a Java. Internal means that it cannot be called by a wallet, so it can only be called by a different function. I think that's pretty similar to private. Then you have external, which can only be called outside, I believe. And a view, this is an important one. Not all your functions have to modify data, right? You can read data, and that doesn't cost you a transaction fee. So these are very, very helpful, because nobody wants to pay $50 every time they got to read data from the blockchain. So if you add that view, modifier, it specifies that this function can be called without having to perform it or update the blockchain. So it's just like a read. They're often like getters are all views pretty much. And yeah, we also have events. Sorry, this is probably like so many things in a row. We'll definitely go through them as we write the code, but just as a precursor, I want to go through these. But yeah, events make it easier to see what's going on the blockchain. You can subscribe to events from JavaScript and that kind of thing, and you can just check what actions have been performed and like update what actions have been performed. So you can create an event with this keyword, call it transfer, and then put in your parameters. So you would call this emit an event, and this would trigger like somewhere subscribing to the event. Okay, lots of talking and going through it. I'm going to take a second to take a sip of tea. Anybody have any questions before I continue? Okay, I'm also going to make sure that everybody has Node.js installed, which I'm sure many of you do. And what we're going to be building is a token. So Ethereum has standards for like interfaces, standard interfaces, and ERC20 is like that's what you use to build a token. So you see so many cryptocurrencies. A lot of them are actually rooted in Ethereum as tokens, and so that's what the ERC20 is. There's also a ERC 721, and that is a common NFT token or interface. And then there's also ERC 1155, which is another NFT type. But we're just going to go through building an ERC20 token. This is what we're going to build is pretty much the standard. We're not going to do anything super fancy, but it'll give you an idea of what you can modify and like you can adjust it to be your own. Yeah, I think we're ready to jump in, unless anybody has any questions. Also, please feel free. I'm kind of trying to watch the chat, but it might be difficult to catch everything. So if I'm going too fast, just you guys should have permission to interrupt me. But yeah, just interrupt me, yell at me. Cool. Let's go through it. I'm going to pull up my notes here. Okay, so let's first open up a terminal and make a folder. So we're just going to go and I'm just realizing I'm going to send the GitHub repo for those that the completed repo. For those that want to just follow along rather than write with me. But you know what? GitHub has been kind of weird today. I was trying to find the link. I'm gonna find. Okay, cool. I'm I'm going to send this in the chat so that you guys can follow along. Yeah, weird. The main GitHub is down. Maybe mine is cached, but it seems that the repo itself had worked. So let me know if you're able to open that. It's if you want to follow along, you don't have to use that. But that's just if you want to look through the code as we're building it. Okay, cool. Let's get into it then. So the common tool for Solidity development is Hardhat. There's also Truffle. Yep, viewing repo is working. Okay, cool. There's also Truffle. Hardhat I prefer. It's just a matter of preference. But it will set up our whole repo for us. So we'll just go ahead, assuming you have Node installed, type npx hardhat, and it will take us through a walkthrough. We're just going to create a basic sample project in the root directory, or in this directory. And yeah, we're just going to hit yes to everything. This will go ahead and set it up. It's also going to say if you're doing it on VS Code, you might want to install Solidity extension. I don't really use VS Code, so we'll see how this goes. But it's common, so I thought I would do it just for familiarity. But yeah, you can try and install that Solidity extension, and it should give some snippets and stuff. And cool. Now that we have that npx hardhat typed in and finished, and again, we just used everything with Y. We're also going to need Open Zeppelin contracts. So we'll install at Open Zeppelin. And Open Zeppelin is just a contract firm. Weird that I have vulnerabilities. Not sure why that is. It's a contract firm and they just have a bunch of tools to use, like pre-built contracts that you can use in your own tests. So let's get started. I'm going to open up this folder that I created. DSC test. And we're going to go into contracts, and we'll create a new token. And just call it token.sol. Solidity is .sol. Okay. And maybe I'll give you an overview of the repo here too. We have just a contracts folder, which is where we will put all of our Solidity. We also have the scripts folder, which is in JavaScript. A lot of this, everything other than Solidity is in JavaScript. There's also Python libraries. I know Cole in the chat uses those. But yeah, it seems to be that JS is the most popular language to do everything with Solidity. And so we have scripts that allow you to create deploys to the blockchain. And then you also have testing. Testing is extremely important in Solidity because you only have one chance to deploy. And if anything goes wrong, somebody finds a vulnerability, you can lose millions, hundreds of millions of dollars. So it is very, very important that you completely test everything that you build. And then the rest of this is pretty common for a JavaScript repo. So let's create our token. First, we're going to, I see. we're going to tell it which version of Solidity to use. We're going to go Pragma Solidity, and the most supported recent version, it changes a lot, is 0.8.0. And so that's just what we'll use. We'll also want to import the Open Zeppelin contract. That is the interface for an ERC 720 or ERC 20. And so this is just an interface that we're going to use to create our ERC 7 or ERC 20. Since tokens also interact with a lot of other contracts, those other contracts support ERC 20 tokens. So you definitely want to be using ERC 20 if you're building a token, and Open Zeppelin just has the standard that a lot of people use. So then we can name our token and create our class basically, which we're going to call contract token, and then is IERC 20 interface. And this will set us up with the basics. Then I'm going to pop open the interface so we can take a look at what functions we want to implement. And cool. So yeah, this is the interface that we're going to implement. There's a lot of comments in here, which is also important. But yeah, there are some comment standards. We're not going to go over those really, but comments are pretty important in Solidity, just to explain what each thing does, and integrity for contracts is very important, given that they can be at a risk. I'm going to see, can I increase the font size? Yep, for sure. Sorry. How's that? Okay. So yeah, I'll continue on with this. There are a few functions, and these are just like a abstract class in Java. We want to implement these. The total supply, which should just tell you how many tokens there are in circulation. And we can see that's a function named total supply. It's external, meaning it will be called outside the contract, and it's a view, meaning that you don't have to pay to execute the transaction. And then it also returns a uint 256. Then we have balance of, which is just another external view reading, and you can type in the address of an account and it will return a balance. Then we have a transfer function. This takes a recipient and an amount, and this is called by the sender. So if somebody wants to send a token that they have in their wallet, they call transfer, and they can put in a recipient and the amount that they want to send. And then we just have a Boolean to confirm that it went through successfully. We also have an allowance. Since this transfer function only works from the person sending, we also want to be able to allow other people to send it as long as the owner allows them to. If if that makes sense. So we can create an allowance, and let's say I want my friend to be able to transfer it when they think is the right time, and I'm going to allow my friend, the spender, to, oh, I'm sorry, this is the checking the allowance. So it's an external view. So again, this is just reading how much I'm allowing somebody, my friend, to spend. Sorry, got a little confused there. And then this is the approve function. So this is what I would call to allow somebody else. So I'm going to approve an address, my friend, to be able to spend a certain amount. And this will just return a Boolean, letting me know that it completed. And then what they call when they have an allowance is transfer from. And they can transfer from me, the sender, and they can choose the recipient and the amount. And then there's some events, a transfer and an approval. So there is like 4 or 5 functions that we actually need to implement. It's not a whole lot, and we can have our token running. So let's start with the variables that we want to have, our state variables. And this is just like class variables in Java. So the first thing we'll want is the name of our token. So we'll go string, we'll go public, and then we'll type name. And then we'll also want a ticker or a symbol. So we're going to do the same, again, public symbol. And so this, we chose public. You can also do private and create like a getter function. Solidity takes public variables and automatically makes them into functions that are getters. So I could call symbol on the contract, and it would return to me the symbol. So it just makes it easier for us with this. And then we also want to create the total supply, which will be a state variable. And we're going to do a uint 256. I don't remember how many 2 to the 256 is, but it's much more than we should need. And then we'll make it public again, and total supply. Okay. What we'll also want to do is we are overwriting this function because Solidity will take our public variable and turn it into a getter, and we want to override the function. So we're going to add in the keyword override. And so this is the first super easy one to create, because this will just override this function. So total supply is covered. We got it here with our public state variable. We can update it from within the contract, and we can just read it the same way as it asks us here by just calling it public override. And then we're also going to want a mapping. This will be for our balances. So we're going to have from an address to a uint. And we're going to make this public again because this will just allow us to call balances, put in an address, and it will return our uint. Cool. So let's go. We have total supply. Let's do balance of. So we'll go function balance of account. This should be an address. And it should be a, oh, yeah. It should be a public view and override, and it should return a uint 256. Return, and we want the balance of an account, so we can just simply use that mapping, go balances, and in square brackets, put our account. Cool. Now I said "oh" there in the middle because I realized I forgot the constructor, which we also need. The constructor is called on the deploy of the function, or of the contract, sorry. So it'll basically set up our contract when we deploy it. Let's see, I see another, yeah, 256 is massive compared to most languages. Yeah, you should be good. So we're going to create the constructor by going constructor, and then we can take in some parameters, and we'll want to set the name and the symbol. So we're going to go a string. We're going to use the keyword memory, which I haven't really talked about, but I'll tell you. And name, I'm going to use the underscore to make it different from the internal name. And we're going to go string memory symbol. So memory is it's usually only for strings, I believe. And basically it tells it that we want to use the machine's memory. We don't want to store it directly to the contract right away. We can use storage, and I'm going to be honest, I'm not 100% sure on how it works with storage. But memory basically tells us the contract, don't save it and spend gas money. We're going to save it ourselves. And so we're going to go name, which is the internal name up here, equals name underscore. And then we're going to do the same thing with symbol. Oh. Okay, cool. So we have the constructor and the balance of. Let's see, I see some more things in the chat. Yeah, that's a good addition there, Cole. If it's declared as memory, it doesn't save that to the big database that is Ethereum. It stores it locally on the machine that's computing the transaction, and so you don't have to pay gas just to pass in a variable. We still have to pay gas here because we're adjusting these variables. And I'm not sure exactly how much gas that costs. You can calculate that. But both these operations will cost us money. Cool. Let's then do transfer. Okay, transfer is a bit of a bigger one. We're going to do another some error handling as well, which we haven't touched on. But let's start with just going function transfer. And we want the address. And a uint. Amount. See, it's a external function. We're overriding it. Oh, sorry, we're going to name it public. We're overriding the interface one, and it should return a bool. Cool. So the first thing that we're going to do is we're going to grab who's sending it. So we're going to go address sender equals, and we're going to use that global variable that I talked about before, message.sender. And then what we want to do is we want to check that the address isn't null or the 0 address. So we're going to use a require statement, and this basically just makes sure of a parameter, and if it's false, then it just cancels the transaction. So we want to make sure that the sender is not equal to the address 0, and we'll give it a message saying sender cannot be the 0 address. If we allowed it to be 0, that would basically just allow anybody to create an infinite supply of tokens. So we definitely don't want that. We also want to make sure that the recipient isn't 0, because then that would deflate our currency. Or allow people to just like destroy their tokens. We don't really want that. We want the same total supply. We can create a different function for that if we want, but for the transfer, we want to keep it the same. So we're just going to check that the recipient also does not equal the 0 address, and we can go recipient. Cool. Forgot to mention this address 0. I'm not sure if you can do anything or other addresses. I think this actually just casts the 0 to address, but it basically is just the null address. Okay, cool. Now that we know that the sender is not the null address and the recipient isn't the null address, we're going to get the balance of the sender. So we're going to go uint 256 sender balance equals balances. We can use this mapping here and just put in the address. And we had that above with sender right here. Okay, cool. Then we want to require that the sender actually has enough. So we're going to require that the sender balance is greater than or equal to the amount. And amount is just how much we passed in there. Cool. Then we're almost done. We just want to update the balance of the recipient and the sender, and then we can return true. So we'll go balances sender equals sender balance this amount. Okay. And then let's do similar thing for the recipient. Balances recipient plus equals amount. Cool. And then let's return true. And we're done our transfer. I feel like I've been nonstop talking, which I have been. But I'm curious if anybody has any questions. I don't want to be too boring and just like keep going through it. Yeah, I don't know. I realize I never usually have questions for these things either, so all good if not. But just take a little breather, I guess. I hope this, can you show the, yes, sorry. I installed Open Zeppelin So I went npm. So sorry, I only installed one package, one dependency. I started it off by typing npx hardhat, and that just took all the dependencies that I need and created my folder structure. And then what I installed was OpenZeppelin. So I went npm install at OpenZeppelin, and I only installed the contracts. I think, yeah. So yeah, hopefully that helps. Cool. I hope, my biggest hope is that I'm not boring anybody. Looks like we still got 9 participants in the chat. So cool. Maybe I'll just keep going then. Okay, we are actually pretty close. We have 3 more functions that we need to make. What we're going to do, and let me just check my notes to make sure I'm on the right track. Okay, so now that we have, we're going to create the allowances. And so as I described before, the allowance is basically allowing somebody else to send your tokens for you. And the process of that is approving someone by calling the approve with the amount that you want to allow them to use. And then you can, the other person that has your approval can call transfer from and move those tokens. So we're going to need a map of allowances in addition to balances. So we're just going to add that in there. Mapping. We're actually going to use double mapping. So we're going to go from an address to another mapping of an address to a UN. And we're going to name it public and allowances. So this is just like a 2D array. This first address will be my friend's address. Let me just double check that my math is right. Okay, so this first address will be me. This address will be my friend's address, and this number will be how much they can send for me. So let's create the read for that so that we can check allowances. So we're gonna name a function, allowance, that takes in a owner and a spender. And then it's going to be a public override and returns a uint256. And so again, this is just to read how much allowance somebody has of somebody else. And so we're just going to return the allowances of the owner has approved the spender. And so this will go through, just who the owner has approved, the list of spenders, and how much those spenders are allowed to use is returned by this function. Getting an error, view to non-payable. Oh, we also want to make this a view because it shouldn't cost anybody to call this function. Cool. Now let's create the approve function. After that, we just have the transfer from, and then we're going to do a little bit of refactoring. Okay, cool. So let's see, what do we need in our approve function here? We need a spender and an amount. So let's go approve function. Approve. And we're going to make it a public override. Returns, and let's see. Boolean. Okay, cool. And first, we're going to start off by just grabbing the. Did I type that right? Yeah, spender and amount. Okay. We're going to check the owner, which is the person who is sending this or calling this function, sorry. Because as the owner, we're approving it. So we're going to be the message sender. And then we want to make sure, again, same thing that we did up here, that the sender is not the 0 address and the recipient is not the 0 address. So we're just going to copy these and paste them down here. Then we want to set the allowance. And I forgot to change this to owner. And cool. And then, yeah, we want to just update the allowance now that we are sure that none is the 0 address. So we'll just go allowances. And then again, like up here, owner and sender and equals amount. And then we'll just return true. Easy. Then, since we have the approve, we can start the transfer from. And so let's do that function. Let's see. Start here. Function transfer from. And that takes in an address, sender, an address recipient, and I keep typing and as I'm saying it, and an amount. And then we're going to make it a public override returns Boolean. Cool. Now, before we write this function, we can already see that transfer from is going to be very similar to transfer. So we're going to refactor this a bit and basically just take this base transfer action, checking that the sender can't be the 0 address. This checking that the sender has enough balance, and then updating the values. So we're just going to take this and put this into an internal function. We talked about that earlier. Those modifiers, internal, will mean that nobody can call it from outside the contract. So it also makes it very secure because we're not trying to make sure that we have the same require statements in every time we call a transfer function. Like if we were to have them separate here, there could be different security risks. If we break it down and just make sure that each function is very secure, it makes it easier and more, can't think of the word for it, but expandable. It's a much better term for that. But yeah, okay. So let's start by calling transfer. We're gonna call it start with an underscore since it's an internal. We're gonna use an address of the sender and the address of the recipient. Then we also want the amount that they're gonna send. Modifiers, we're just gonna call it internal. I'll start, yeah. Speaking before I think. We're gonna take this and we'll take it out of there and we're just gonna put it in here. Then we can modify the variables. We see sender and recipient. We actually don't have to do anything within this function, but we have to update our original transfer. So what we're going to do is we're just going to call that internal transfer from this transfer with our values. So sender, we're just going to put, see the chat, I'll address that in a second. Transfer sender, we're going to go message.sender. And then we're going to go recipient, we keep that, and amount. And we can get rid of this. And that was pretty easy to refactor. Just had to move it over there. I'm going to check the chat here for a second. Yes, yeah. So private. Oh, yeah, that's a good idea. Okay, yeah, okay. So that internal modifier here, this means that it can only be called within like a protected class in Java. I think that's what Cole is saying. So it can only be called within this contract. And then private is the same as private in Java classes. So if it's internal, child classes can still access it. Okay. Yeah. If it's private, they can't. Okay. This is why my non-expertise in Solidity is coming out. I am more in the Web3 stuff, but yeah. Cool. Okay. Now that we have this internal transfer, we can call that in transfer. What's our next step? Sorry. We're also going to make an internal for approve. We're going to want to update the approval amount after we use it in transfer from. So we're just going to do the same thing. Go function approve address owner address recipient. Oh, sorry, address vendor and unit 256 amount. Then we're going to go internal again. And what we can do is just take this, paste it in here. Let's see, I don't think we have to change anything. Nope, that should be it. And then we just have to update that approve up here again. And we're going to call approve with the message.sender. And the sender and the amount. By the way, just looking at the time here, looks like we're at 1 hour and 3 minutes. Probably won't take more than 15, 20 minutes. I'm also just going to go over quickly testing a function. And we have like maybe 5 minutes left in this contract. And then I have some good resources for you guys to share at the end. So let's just continue through here. Okay. We have this proof here, nice and easy, and we have approve and transfer both abstracted out of there. Now we can do the transfer from, and so we're going to start by calling transfer from the sender to the recipient and the amount. And then we're going to check the current allowance. So a thing to note here is that it may sound weird making sure that our sender, or that we're checking the allowance after sending the token. I believe, so I as I was looking at this earlier, putting this together, I was also confused, but from what I believe, and somebody can correct me if I'm wrong, is that the function will not go through if any requires are missing or are false. So if we call transfer if we call transfer, go through this, and then we check current allowance, as long as we fail that, it won't go through. I believe this is where you should do more research, and don't listen to me, because if I tell you to do something wrong and you lose, I am correct. Okay. The transaction reverts if the required is false. Okay. But yeah, regardless, still do your own research. Make sure you're doing the best security due diligence, because it can be the stakes are high. Okay. After we have this current allowance, we can just require that the current allowance is greater than or equal to the amount. And then if not, we're just going to warn them amount exceeds allowance. Then we're going to update the allowance since it was partially spent or fully spent. And we're going to put in the sender, the message dot sender, because we want to update the sender's allowance. And the current allowance minus the amount that we sent. And then once that's all done, we can just return true. Yeah, okay. Cool. Now we have just one last thing to do, and that would be the events. So interfaces, events, we don't have to override. We can just use them from the interface as we imported them here. And all we want to do is emit transfers and approvals, since we have those both in here. So we're just going to add those, since anytime anything is transferred, we use the transfer function. We're going to add that at the end, at the bottom of the transfer function, and we're going to go emit transfer from the sender to the recipient and the amount. And then we're going to do that in approve to. We're just going to emit approval from the owner to the spender and the amount. Cool. And that's our token. So yeah, hopefully that's a good understanding. Basically what we've wrote so far, just as a recap, is that we have these state variables, the balances, allowances, total supply, and the name and the symbol. Name and the symbol, you don't really need them. I don't even think yeah, it's not required even in the ERC20, but it's something common that people use. And then, yeah, you can check the balance of an account with this. You can check, or you can create a transfer and allow somebody else to transfer using the allowance. And yeah, you've written a token. Hopefully that gives you a better idea of it. What we're going to do next is we're not going to deploy it to Ethereum because that would cost probably, I don't know what the gas fees are right now, but probably $200 to $300 to $500. So we're not going to do that. More than that, yeah. Probably 5 to 1,000, I would say. But yeah. Okay. What we're going to do is we're going to write just one test, just to give you an idea. If we wanted, and in practice, we should be doing a lot more tests, but we're just going to write one to get started. Another thing that I'm going to add here is in the constructor for our tests, and you may want to do this when you initially, like for the contract, regardless of tests, is that we want to set an initial balance. Without an initial balance, so there will be like no tokens in circulation. So we want to just do that by going balances. And we're going to give the deployer sender, message.sender, 100 tokens. And then we also want to update the total supply. Cool. Now we're ready to write our test. So we're going to open up this test file. I'm going to move it over here. I don't really need that anymore. And I'll make this bigger. So this greeter is what they put in here initially. It's just a very basic contract. Hard Hat deploys it for you. And then they set up your testing here as well, which is super nice. And they just test the greeter one. So what we're going to do is we're just going to, and I'm not really going to dive into the JavaScript. You don't have to follow along if you don't want. We're just going to give you an idea of how it works. So we're going to describe the token. And this is also something that we'll go over more kind of in the part 2, because we'll be using more like JavaScript and building our front end that will connect to this contract. Should deploy the token contract. So this describe is a greater, like bigger section, and then we can create its for each test. And so we're gonna put a async function in here. If you haven't done any JavaScript, this is probably pretty confusing, but it shouldn't have to focus on it too much. So what we're going to do is we're going to deploy our token with await ethers this is getting our contract that we created in our JavaScript file. So we're going to get that contract with ethers.get contract factory, and we're going to get the token contract. They did that up here with the greeter, and so we're just doing this with token. We're then going to deploy it with await token deploy, and we're going to name it my token, and we're going to give it the symbol of PKN for token. Then what we want to make sure is expect, and sorry, this returns our instance of the contract that was deployed. And so we can call our functions on that by going, token dot name, and it should be dot to equal my token. Okay, and this is just using the public getter that we created by using the public keyword here. And then we're also going to copy this and check that the token symbol, if that's what we called it, is equal to TKN. Cool. And we can go back over to our console here, and we can, I believe it's npx hard hat test. And if I did that right, we will test our contract. Yeah, it's giving me this warning here just to add a license to my contract. It's not a huge deal if you're going to deploy it for sure. But yeah, and we can see that this is the one that they had in there, that the greeter is working properly, and then we have token, and it should deploy the token contract. And that passed. So yeah. I also have a function here for transfer. Since we're going a bit over time, I'm just going to copy this and show you. There we go. My headphones just said that they disconnected. Are you guys still able to hear me? Just want to make sure. Yeah, it looks like it. Okay, cool. Sorry about that. Okay, so this transfer, it should allow an owner to send a function. So we can get the contract again, like up here, deploy it with the same name and ticker. And then this ethers.getSigner allows us to use different wallets. So this takes the owner wallet and the Alice wallet. So the owner wallet is the one that deployed it, and then I just named it Alice. You name it whatever, and you can continue on. Like you can name Bob, and you can get a bunch of different wallets to test with. And it always uses the first one by default. So we can check transfer. We don't have to specify who's going to transfer it because we know that it's owner by default. So we're going to call token transfer to Alice's address, 100 tokens. And we know that we gave the owner 100 tokens on deploy. So then we can check that the balance of the owner is 0 and the balance of Alice is 100. And we can run that again by going npx hard hat test. And boom, we have another one for transfer here. So yeah, you would go ahead and continue lots of tests, as many as you can. Because as I said earlier, like the stakes are high and it's nuts the amount of things that can go wrong. There's been recently one of the biggest hacks was for 600 million on the Polygon or Poly network, not Polygon. And then next to that, there's tons at like 60 million, 50 million. It's insane. So, and a lot of people are they go anonymous, like a lot of developers in the space. So it's interesting. You don't find it anywhere else, and it's just nuts. I have some links here. I'm going to send this in the DSC club too, or the DSC, the Discord. And yeah, next weekend I'll be doing a Web3 one, which this contracts are okay. Sorry, I got distracted by the chat. Contracts are like the back end of an application in normal Web 2 is what they call it, or what we call it. In the Web 3 space, blockchain, you don't really need a backend, which is actually why I really like it. I began in the Web 2 space not liking backends, and I only built front ends. And then I found out about this, and I was like, okay, sweet. This is much more interesting than like a node database that I'm creating. Like I'm not creating a REST API to just update a database. This was like way more exciting and just very different. So yeah, the next part two, I'm going to be building a website with you guys that connects to the contract and can like use a wallet in your browser to make transactions and send stuff. And yeah. It's also worth noting, I didn't put in here, I didn't really tell you how to deploy contracts. You can look through that on Hard Hat, but I didn't think it was like, I don't believe it's super difficult, and you can look it up on your own. But you can deploy to test nets or a local network for completely free and do some testing. You can also do local network and what's called cloning mainnet or forking mainnet. And so you can basically test on your local machine as if it were on Ethereum. All the data from Ethereum you can pull in and manipulate on your local network. And then, yeah, as I mentioned earlier, ETH Global is, I highly recommend checking out any of their hackathons. It's so much fun, and you meet, the community is so small that you meet extremely valuable people that are super nice, and everybody just like wants to collaborate. And I've met developers who have been in here for since the beginning, writing contracts for 5 years, and they like kind of help me up. And it's just such a cool community of people that love to connect. And I haven't found any other value similar to it in any other type of area in computer science. Gone to other local hackathons, and they're great. I would recommend going to. I think we're going to do one as ESC, but these are completely global. Everybody around the world coming together. Another thing, here's a tutorial that I added. This is what I use to kind of learn Solidity. I think I have it in the DSC chat. I think Rahul, I sent that to you earlier. But this is a good tutorial to cover the things that I didn't cover. It also goes way past what I covered. And it's really fun. It's like an NFT game that you can you build, and it holds your hand through it. I think it took me like, I don't know, 4 to 6 hours to go through. So it's pretty good. Another one for concepts, I've kind of just taught you the sorry, loud noises upstairs. I've kind of just taught you the like code part of it. There is so much that goes beyond the little snippet that I've showed you. There are incredible financial products, like NFT projects, metaverse. Like it just goes on and on and on of what these different like emerging technologies. And Finematics has been, for me at least, a good way to understand DeFi, decentralized finance, which is one of these areas that is just super interesting to me. He breaks it up really well. It takes a couple times of watching through them and understanding them, but he goes through the basics that have been built on recently, and it's pretty up to date. Then here's another link for more courses. ChainShot has some free courses that you can go through, and yeah, I'll post these in the Discord group. And yeah, I've kind of said this before, but this I'll keep going. This is just an incredible space to be a part of, and at the like last winter, I was kind of freaking out like everybody, trying to find a internship. And even with COVID, like there was no way I was going to get anything, I felt like. And I was stressing about that. And then I went to this hackathon and met people that didn't really care about my experience. Everybody is new and just there's a demand for developers. So everybody just wants people to become a part of it. A lot of people in this space also were not developers before. There's also even like marketing jobs, community management is a big thing. So like even Discord mods, um, and like hosting weekly meetings and stuff. It's a very easy way to get into emerging technology. Um, and yeah. So Rahul is asking if there's co-op positions in the space. I think I saw that Uniswap is actually has co-op. They're hiring for sorry, not co-op, but internships. With co-op, I'm currently in Capstone right now, and I don't I don't think you would find anything like that. A lot of these companies, I mean, they're all over the world, but there's not that many in Canada. There's a few, like Dapper Labs is in Canada. Um, and so I believe it's more difficult to do a co-op through the school, but there are definitely internships. I would take a look at Uniswap. Uniswap is the like number one project on Ethereum, pretty much, from one of the beginning ones. And they were looking for interns. Yeah. I'm trying to think of what else. Yeah, I'm also starting my own company. Not really hiring at the moment. I would tell you guys, but yeah, this space has just been incredible, and I would definitely recommend everybody to at least give it a chance. What's my company? So we are called Increment, and it's a very like trade thing. But if you're familiar with foreign exchange markets, so like Canadian dollar versus US dollar or European dollar versus US dollar, that's a very big thing called like Forex in traditional trading. And so, yeah, so what we're doing is we're bringing that on chain. So we're using price feeds and basically creating Forex trading. We're going to do perpetuals, which is a type of derivative. And we're allowing people to short or long different currencies. And yeah, we've like a, yeah, just again crazy opportunity. And yeah, I hope this. I think this is my last slide. Yeah, this is another NFT I stole from Snoop Dogg. um, but yeah, I'm. If anybody has any questions, feel free to like ask them in the chat or unmute and let me know. Otherwise, I'll probably just sit around for the next 5 minutes and then call that a day. And thank you. I'm gonna stop the recording now.